All right, guys. This is gonna be the next page of your notes. This is chapter 10. It's going to be the last chapter before our test slash project. I haven't really decided what I wanna do with that yet, but we're gonna move on. Chapter 7 is observational studies and experiments. Students will be able to recognize purpose and difference of sample surveys, experiments, and observational studies. Okay. So your homework is page 259, numbers 1 through 10. It's going to be like wordy, and it's like the homework problem is going to be wordy. But most of it's multiple choice. Some of it, half of it's like multiple choice, and half of it is different parts. Really dig deep and try to kind of understand what is going on with this problem. Actually, I'm gonna change it. I'm actually gonna change it to 1 through 8. Sorry, I'm gonna change it to 1 through 8 all. Okay. Okay. Cool. Okay. Let's get started. I already read that. Observational studies. So the first type of thing that we're gonna do is this thing called an observational study. It's a study based on data in which no manipulation of factors are employed. So what that means is you're just observing, you're just watching. You're not really doing anything, you're just watching. Okay, you're just watching it. And there's two main types of observational studies. The first type is called a retrospective study. It's an observational study in which subjects are selected. So what you're doing is you're selecting people. Then their previous conditions or behaviors are determined. Retrospective studies need not be based on random samples, and they usually focus on estimating differences between groups or associations between what's called a variable. Okay, so a retrospective is the idea that you're looking kind of at the past. Okay, a retro is past. You're looking at the past to pull information from. So example, if I wanted to see if band kids got better grades than non-band kids, then I would look back at their past grade. That's a retrospective. I'm looking at the past, what's already happened. Because retrospective studies look at historical data, they can have errors. Old data can be wrong or forgotten, okay? So retrospective study, depending on how they did in the back, because we're not doing it, we're looking at old data. Those old data could be wrong, and because they're wrong, they can throw up our retrospective study. The other type is called a prospective study. It's an observational study, so once again, we're watching, we're observing, in which subjects are followed to observe future outcomes. Because no treatment are deliberately implied, a prospective study is not an experiment. Unlike retrospective, prospective studies identify subjects in advance. So when we're doing retro, we're kind of looking at everything as a whole in the past. A prospective study, we're actually doing the study ourselves. Sorry, both studies we're doing it ourselves. Retro's just looking at the past data. Prospective is we're kind of making our own data up in the present. Okay, because we're making that data up in the present, we're still not, because we're making that up, we're identifying subjects. Who are we going to survey? Who are we going to run lab tests on? Who are we going to do physical exams on? We're focusing on that. So the two big things is retrospective. You're looking at old data in the past. Prospective is you're doing the data now. Okay, that's the big one. And what we mean by doing the study is once again, we're not going out there. If I want to test if nicotine is addicting, I'm not going to go out there and give a bunch of kids or my subjects cigarettes, right? That's called an experiment. When you're going out there and giving them stuff and then testing them, that's called an experiment. A study is just naturally what happened. I would go out there and I would just look for people who already smoke and track their health. Okay, before I move on to this slide, just to make sure that you guys are watching this video, we're going to do the same thing as always. You guys are going to go into the Google Classroom comment or whatever, and you guys are going to comment in this topic. What I want you guys to comment is, give me a suggestion on something to watch, either on Netflix, Hulu, or even Amazon Prime. Yeah, give me a suggestion of something to watch. Okay, cool. All right, so those are our two types of observational studies, right? Like observational study is this umbrella. And under it, we have two types. We have prospective and we have retrospective. Okay. All right. Observational studies do not determine cause and effect. Observational studies don't tell us like, oh, this happens because of this. We don't know cause and effect according to observational studies. So just keep that in mind. Okay, here's our first little problem that we're going to do. In early 2007, a larger than usual number of cats and dogs developed kidney failure. Many died initially. Researchers don't know why, so they used observational study to investigate. Suppose you were called on to plan a study. What would your design be, retro or pro? This one would definitely be a retro. What the couple reasons why I believe that this is retro. The first reason why is that the first thing is it happened in 2007, right? Like this thing occurred in 2007. So that's kind of the first indicator that it was in the past. Another kind of idea. Sorry, let me think so I can word it correctly. You wouldn't like a prospective is you would go out and survey the cats and dogs, right? But that would be impractical because there would be just so many and you wouldn't really like figure out like what did what. It's better to look at old data to look up which cat and dog died according to that. You wouldn't go out and look for new cats and dogs, right? You would go back in 2007 and track records of the old ones. Okay. I think that makes more sense to look at old data to locate some that were already sick rather than try to find new ones. Okay. The next type of study that we're going to do is what's called an experiment. An experiment is something that you guys should know. You manipulate factor levels to create treatments, randomly assign subjects to treatment levels. Then you compare the responses of the subjects. We use random assignment. An experiment must assign experimental units to treatment at random groups. So remember, in an observation, you're not really doing anything. You're just looking. In an experiment, you're actually going out there and you're doing something to the subject. That's the two big difference. In an experiment, you want to use random assignment. You don't necessarily use... Whoa, that was weird. You don't really use random assignment in observational study because you're just observing people. You're either observing old data that people already have, or you're going out there and people that fit your category you're observing. Okay, but in an experiment, because you're performing this, you wanted to use random assignment. So the three big things is this thing called a factor. A factor is a variable whose levels are manipulated by the experimenter in order. So a factor is kind of like the thing being tested. Tested thing. I'm pretty sure there's better wording for that, but it's the thing getting tested. Okay. So back to my example of tobacco in general. No, that's bad because I don't want to tobacco people up. Let's say I'm testing a new medicine, right, to see if it's effective. Then the factor would be the medicine. The response is a variable whose values are compared. So once you give your subjects the factor or whatever, right, or whatever you're testing, either it's medicine or whatever the experiment's on, they're gonna feel some sort of way. They either like based off of their health or certain things. That thing is called a response. Okay, how they react to it, it's called a response. Humans in an experiment are called subjects or participants. Other individuals are called experimental units. So once again, a factor is the thing that we're kind of testing. It's a variable that we're testing. Whether, for example, if this medicine is effective, then the medicine itself would be a variable, aka a factor, and how people feel after we give it to them, that's called a response. The specific values that the experiment chooses for a factor are called the levels. So if you were doing an experiment on sleep deprivation, then you can assign different levels for them. So if I'm testing to see like how people respond to different levels of sleep, I wouldn't just of sleep. Sleep would be the factor. Right? Sleep would be the factor, but the levels would be 4 hours, 6 hours, 8 hours. Treatment is the process applied to randomly assigned experimental units. So treatment are the different levels of the factor. That's called different levels. So in this example, our treatment would be 4 hours, 6 hours, 8 hours. And those are the things that I'm doing to people. I'm going to give them 4 hours of sleep, 6 hours of sleep, or 8 hours of sleep. That's my treatment. Okay? I'm treating them at different levels. So let's look at this example right here. In 2007, once again, it's about the pet food. The manufacturer now claims that the food is safe. So now they say that the food is safe. But before it can be released, it must be tested. An experiment to test whether the food is now safe for dogs to eat, what would be the treatment and what would be the response variable? I think I totally deleted a slide. Sorry. So before we can even go to this example, did I even talk about response variables? Yeah, I did. Okay, cool. All right, so we did talk about response. The response variable is like the response, how they feel, okay? So what would be the treatment? So treatment 1 would be the new food, the food that we're being tested, right? Treatment 1 would be the food being tested. Treatment 2 would be food that's known to be safe. Okay, so I'm testing to see if this new food is actually not going to kill them or is okay for them to eat. So of course the new food would be one of the treatment, and then I want to compare it to something. I want to compare it to the old food, or not the old food, but food that I know that's going to be safe. Okay, so you usually want to do two different things like that. You want to do one where you want to test like new food, or you want to test the new thing versus something that is known to be safe. The response variable. How would we measure this, right? So the response variable would be the health of pets, right? The response variable would be the health of the pets. Okay. That's how we can tell if the food is safe or not. Okay, because that's how we measure it. Okay, we're measuring to see we're measuring to see. 10. So in an experiment, there's 3 big things that you want to talk about. The first thing is called a control. Aspects of the experiment that we know may have an effect on the response. The thing called randomize, like we want to randomize. And then replicate. We want to do the experiment again. Like we don't want to just do the experiment one time. We want to do it again. Okay. I want to talk about control because the other two are pretty straightforward. Randomize, like you just want to randomize who's getting what. Replicate is like you want to do the experiment again with new people. But control is you want to make sure that everything else that's not being tested stays the same. We want to control the sources, okay? So kind of in this last example with the dog food that we're talking about, right? We'll talk in the next section because I think the next problem actually takes care of it. Yeah, let's talk about this slide right here. We're planning an experiment, and then we'll feed some animals the new food, and then we'll feed some animals food known to be safe, right? That's what we kind of talked about. Those are our two treatments: the new food, and then this food that we know to be safe. How will you control the principles? How will you implement the principles of control? Okay, what you need to do is you got to make sure that whether or not they're in the new food or the old food, everything stays the same. So the amount of food is the first thing. Amount of the food is the same. Like you want to make sure that the portions are the same within your two groups. Okay, you don't want to give one group more food than the other, because then that can kind of change up your experiment, right? If you give one group more food than the other, maybe they're more unhealthy because they get more food, right? Like you're increasing that, you're increasing their food, and that's the result of that. So to take that out, we're gonna make sure that they're the same. Okay, I would just sometimes you don't have control, but it's nice to say it. You want to make sure that the housing are the same. Right? Like you want to make sure that the dogs are kind of like in similar or same housings situations, right? Like if you have a dog that you picked up from the street, like a stray, versus a dog that's lived at indoors the whole time, that can throw something off, right? Like the stray versus like a dog that's been at home. Like you want to pick like one category. Like if you're gonna pick strays, pick strays. If you want to pick homes, pick all your dogs that or house dogs, I guess would be. There's other things like you want to make sure dog ages are the same, right? Like you don't want to pick like a puppy who's like kind of healthy, more energetic than like an old dog who's like old, a little older, right? That might have health. What else? There's so much. Sleep, like you want to make sure the dogs get the same sleep. Play/exercise, they get the same amount of play exercise, and like the list can go on. Like you can keep going on with this, but the idea is that you want to control all these things. Like you want to make sure that both groups and every dog in those groups have the same thing, right? Have the same or very, very similar things. Okay. Randomization. How would you randomize? I don't know. I would use an SRS. Why? SRS to split into two. Like I don't know. Like you can give each dog a number, and just pick like number 5, and alternate. As long as you have some sort of system, like and you pick numbers from a hat, and the first 10 numbers, those are going to be your experiment. Then the rest are going to be your sorry, not your experiment, the new food, and then the rest are going to be the safe food, right? So you want to randomize. So I'm just saying using an SRS, maybe an SRS, assign numbers, and draw them to split into two groups, right? And you can do anything you want as long as you're being random with it. Okay. And then how would you replication? That just means I would just do it again. Do it again with new dogs. Right? Do it again with new dogs. Maybe different breed. different breed. Do it with competing genders, male and female. You know, like run an experiment with all male dogs, do an experiment again with all female dogs, and so on and so forth. I would just do it again. The more that you do, the better it's going to be. Okay. So this is kind of just like a diagram of the experiment. Like you randomize group 1, group 2, treatment 1, treatment 2. So in our example, it would be new food, and then I'm going to write safe food. And then you want to compare the health. And then what would our response be? It would be the health of the dogs, right? Mm-hmm. I actually do want to go on. Slide 13. Statistically significant when an observed difference is too large for us to believe that it is likely to have occurred by chance, we consider the difference. Dude, what is wrong with my spelling in this slide? To be statistically significant, meaning when something's like kind of out of place, if there's something out of place, then that's pretty much like an indicator. Be like, oh wow, this is out of place, this is significant, right? If you running back to this dog experiment, the safe food and the new food, if you found how, I don't know, let's say we tested 20 dogs here, 20 dogs here, 20 dogs here, and you found out in group 1 versus group 2 when we're comparing, let's say hypothetically in group 1, 10 dogs were, I don't know, unhealthy, whatever that means. But in group 2, I don't know, 3 dogs were unhealthy. That difference between 10 and 3, you know, that's significant. That's a big change. If it's like 4 versus 5, then they're very similar. Then maybe they're the same. But because it's 3 and 10, that's a big gap, right? If it was smaller, like I said, 4 and 5, maybe not. But then you would run it again just to make sure, right? The more you run it, the better idea you can get. All right. Last slide. Gastric freezing for chronic peptic ulcers is a non-surgical treatment which was popular 20 years ago, but is now seldomly used, so we don't really use it anymore. It has been abandoned due to high complication rate, only temporary improvement experienced by patient, and a lack of effectiveness when tested by double-blind control. Don't worry about double-blind controlled. What did the controlled clinical? Okay. Ignore that, right? Ignore those words. What was the factor? Okay, what are we testing? Okay, we're testing effectiveness of gastric freezing. That's what I'm testing, right? I'm testing that process. What is the response variable? What is the response variable? Okay, so how do I know? Okay, maybe it is the health of patients. Right? Like that's how I would be able to determine whether it's effective or not, by the health of the patients. C, what were the treatments? So treatment 1 would be the gastric freezing. Gastric? That's stupid. Gastric would be the gastric freezing. Right? Treatment 1 would be the gastric freezing. Right? Meaning the actual surgery or whatever the process. Treatment 2, you want to compare it to something. You want to compare how effective it is. So you want to compare it to, I don't know, to an alternative procedure known to be effective. So you want to compare it to something that you know that already works, right? You want to compare the two to see to compare numbers. Part D, how did researchers determine? So I would randomize, right? You would randomize. You would randomize patients between two treatments. Then were the results significant? No. And the reason why it's no is because it says right here, a lack of effectiveness. Right? Because of that lack of effectiveness, obviously gastric freezing was not effective. Right? It did not work. That's the idea. Okay, that's pretty much all I have for today. In terms of that, this stuff gets like I said, mathematically, like there's not much math. It's just a lot of vocabulary, and you guys really just understanding what is what. Big takeaways that I want you guys to focus on for this lesson. Make sure that you know the difference between retrospective versus prospective. Remember, these are both observational studies. Okay, and then the next thing in an experiment, factor, response, variable, treatment are the three big ones, and then control. I'm just gonna write on this side. Are the three big things, or four big things. Okay. All right, yes, that's all I have pretty much for today. Have a safe Monday through Thursday or whatever. Yeah, yes. Be good.